So as part of your HDFS, you have three daemons: name node, a backup to the name node called secondary name node, and you can have one to any number of data nodes. This will exist only one. This also will exist one, and this is 1 to n. Data node or nodes. So your secondary name node always works as a backup to the name node. Backup to the name node doesn't mean when the name node is down, the secondary name node will not come into picture automatically. Only the file system metadata, I mean, what is a file and what blocks are there? I mean, how many blocks are there and where those blocks are located, only those details will be stored. That is what we technically call it to be file system image. In short, we call it as FS image. So whenever there is a transaction happening to your file system, I mean, either you are creating a new file in the Hadoop distributed file system, or you deleted some file, or some file got modified in terms of the data, whatever. All these we call as transactions at the operating system level. Operating system level, I mean Hadoop distributed file system level. Now these operations results in changing the metadata. That is, the changes will happen as part of the file system image. The changes will happen as part of the file system image. Now this is being tracked and being backed up by the secondary name node. In the event of your name node down, you can either up the name node directly by rectifying the faulty hardware. If something goes wrong with the Hadoop distributed file system, that is FS image, it got corrupted or something like, in that event, we take the backup from the secondary name node and construct the name node back and start the name node. Then only your cluster is on. We say the cluster is active or on only when the name node is active or available. If the name node is down, secondary name node will not come into picture automatically. It only serves as a backup. At times when it is required, you are going to take the backup from the secondary name node and construct the name node back. That is why sometimes we call name node as SPOF, S-P-O-F. That means single point of failure. Single point of failure. Single point of failure. If the name node is down, the entire cluster is down. If a data node is down, only the blocks pertaining to the files, only they may not be available temporarily, But you know, data being replicated, if the data node is down, no problem, still the data is being made available in the other nodes, as usually we keep the replication factor to be 3 at the cluster level. So even if the data node is down for any reason, still the data is being made available. But if the name node is down, till it is up, the cluster becomes unavailable. Because if the name node is down, even the job cannot run, for the reason whenever you submit a job to your job tracker, the job tracker is going to internally communicate with the name node. The job tracker is going to internally communicate with the name node. Why? The job tracker should know where the blocks for the given file to be processed are located. If the name node doesn't respond where the blocks for the given file are located, then job tracker also cannot execute the job. So if the name node is down, not only your storage becomes unavailable, your processing also cannot happen. Because in order to process the data, I should know where the blocks for the given file are located on your cluster. I hope you got the point what I am saying here, Laden. SPOF, single point of failure. We call that to be SPOF for the reason. For any reason, if the name node is down, the entire cluster becomes unavailable. That is why we call that as SPOF, single point of failure. Single point of failure. That makes sense?
Yes.
So, in the event of your name node failure, if the file system image is okay and there is some other hardware failure and all, then not an issue, not a problem. We can rectify those and make your name node run properly. Then your file system is back. For any reason, if the file system got corrupted, then we take, the name node hardware, that is your hard disk. If the name node hard disk got corrupted or burnt, then the only way is to take the backup from the secondary name node, construct your name node, start it, then only your file system becomes accessible. Then only your cluster is accessible. Till then, your cluster is inactive. Let it be 5,000 node cluster or 10,000 node cluster or 50,000 node cluster. The entire cluster becomes inaccessible if it is down. That is why, looking at its importance and its need as part of the Hadoop cluster, over a period of time, eventually they started removing the dependency of the secondary name node by making name node itself more reliable, secured, so that data can always be made accessible. So we talk about those aspects. We have Zookeeper. With the advent of Zookeeper, you can make your name node to be highly available. So we don't need secondary name node in the current IT, in the current big data landscape. Even without your secondary name node, you are able to make your cluster available all the times. We have that kind of implementation. But as we need to study the concept, we are now going through name node, secondary name node, and all these things. But secondary name node is almost obsolete now. With the new changes in the architecture of your Hadoop cluster, secondary name node is almost obsolete. It is no more required. with the advent of Zookeeper and all. So we study those things at the later stage. So when it comes to the HDFS daemons, we need to study about each and every node in detail. So first we have name node. Yeah, Vladan, can you say something about the name node? What you have studied and what you have understood?
Name node is practically process runs on a separate computer.
Okay.
So it practically gets not the instruction, but it gets the requests from the job tracker, and then processes those requests about like where data is stored, and gets actually the jobs from the job tracker and communicates with data nodes.
Okay. Go ahead, because I would like to just hear from your end so that I understand what is your current understanding on the concept so that I can teach you the rest of the stuff. That is what my intention.
So yeah, then yeah, as you said, it's a single point of failure. So if it's down, we can't. The whole cluster is not functioning. So
Yeah.
So as I understood, because I was reading from Apache.com, so client communicates to data node to name node. So name node communicates to data node, and then name node kind of connects client to certain part of cluster where actual data is stored.
Yeah. You're right. You're absolutely right. So you look at this one, you will be able to understand. You have a look at this cluster. I think this diagram is more. This is a true Hadoop cluster. I mean, large setup. I'm saying. Whatever you are seeing here, all those are your rack servers, right? Not like tower servers. Because we don't go with tower servers in the true implementations. They're all going to be rack servers only, right? So you'll have a rack. In that rack, you'll be seeing all the servers kept horizontally, and you'll be having typically each rack server will have a storage of at least maybe 8 to 10 TB and two processors definitely of a reasonably good capacity, like 4 cores in each, at least 4 cores in each, and memory in the sense RAM of around I say around about 256 GB. Usually, you can set up your Hadoop cluster with any commodity hardware. Commodity hardware, I mean any normal hardware. Okay, it need not be enterprise class. It need not be enterprise class. I mean, like the hardware we use to set up your traditional RDBMS. So we take a lot of care in finalizing the setup of your enterprise data warehouses, where you will have your traditional RDBMS being set up and other things being. So we don't require enterprise class hardware. It can be even commodity hardware. Commodity hardware doesn't mean you buy the parts individually and you assemble it. So we don't. Usually we don't, but it is possible. It is possible to set up your Hadoop cluster with any kind of hardware, because your Hadoop cluster is built on the top of the principle. Even in the event of hardware failure or any reason, if any node is down, the cluster is unaffected. Even if the cluster is, even if the node of the cluster is down, still the data is being made available. It is being developed based on those principles. So even in the event of your node failure, still your cluster is available. Only in the event of name node, when the name node is down, your cluster is unavailable for some time. Once you bring back your name node, then your cluster is active again. So you look at this diagram closely, you understand and appreciate. So this diagram should be in your mind permanently. Then only your imagination is going to work out properly. So even sitting under a tree, you can start working on a cluster, imagining. You don't need the cluster at all. You don't need the cluster at all. You just need to have this imagination in the mind. Of course, you are going to work on the live cluster or a pseudo cluster and get the hands on. Thereon, if you want to study something or you want to get something, you should be able to visualize the cluster and get all the points or concepts without you physically interacting with your cluster and trying to understand. I think you are getting my point. That is why I want you to engrave this kind of a picture in the mind, how a Hadoop cluster is going to be. We can have number of racks. In each rack, we'll have a predefined number of servers, usually in the range of 22, because usually the switch will have 24 ports. Each rack is equipped with one switch, and each rack can accommodate 22 servers, rack servers, which are usually horizontal. Tower servers means they are like, the old CPUs at home. They are called, if a server is in that model, we call them as tower servers. Tower servers are expensive in terms of space and resource consumption. I mean power consumption and all. That is why we always set up on a rack server. We'll have a rack. All the nodes in that rack are connected to that switch, that is rack switch, and all such switches are connected to the next level switch, and all such switches the next level. That is how the hardware is been made accessible. So thereby you'll have ever growing cluster as part of your Hadoop ecosystem. So each node, I mean each server on your Hadoop cluster takes one responsibility. You take your name node is being set up on an individual machine, secondary name node on an individual machine, and job tracker on the other individual machine, because all these three daemons, I mean the process, are going to consume a lot of resources. That is why it is good that these daemons are going to run on independent machines, usually these 3 machines are high configured compared to the data nodes what you have as part of the cluster. And we can have 0 to n data nodes where task trackers also coexist. Task trackers also coexist. Look at this diagram, then you'll be able to understand. Make sense, Ryan?
Yes.
So in your pseudo cluster, you cannot have multiple data nodes. As a result, you cannot have data replication. That's the only limitation which you see as part of the pseudo cluster, which you have set up using your respective bundles. Maybe whatever, a VirtualBox based bundle or VMware based bundle or even KVM based, or even we can have Docker images these days, any mode. So which is being set up on a single machine, but all the daemons are going to function for you and renders the respective services. That is what we technically call it to be. That is what we technically call it to be pseudo cluster. Let it be pseudo cluster or a full-fledged cluster, the services are going to remain the same. So that's where you need to have the understanding. Hope the theory what you have gone through might have given you. Look at this diagram very closely. Then you understand why data replication is needed. I would like to ask you one thing, Laden here. Why replication is needed? Because it is expensive, especially in the context of big data, it is more expensive. Why we need data replication?
But as I understand, it practically works as a RAID array. So it replicates itself. Like in RAID array, we have multiple hard drives. Over here, we have multiple, it's a cluster. We have multiple machines. So all those different blocks are stored, like the same data is stored on multiple machines because of the data recovery. In case if one data node fails, then it can be recovered.
Absolutely right, Laden. Appreciate. Because as a Hadoop cluster can be set up even on the commodity hardware, as Hadoop cluster can be set up on the commodity hardware. Commodity hardware, I mean not just assembled. Commodity hardware is also the hardware that is from vendors like Dell, HP and all, but they are less expensive compared to the enterprise class hardware. So when you are able to set up your Hadoop cluster on the commodity hardware, there is every chance a node may get failed. Whatever the reason, when you are having more nodes, there is every chance that a node may get failed for whatever the reason. Maybe a very simple reason like the power cable got disconnected, or the network cable got disconnected, whatever the reason, or the hardware might have got burnt, whatever it is. So for any reason, if the node is down, if you want, for every small effect on your cluster, like a node is down, I have a cluster of 500 nodes. I have a cluster of 500 nodes. Okay. When I have a cluster of 500 nodes, when one node is down, the entire cluster becomes inaccessible, is not acceptable. When my cluster is down, I mean, cluster becomes unavailable as a result of one node down is not acceptable. So keeping that aspect in the mind, we have compromised with the storage by replicating the data on multiple nodes, so that how this distribution also happens, the distribution of the data also happens in such a way, even if one node is down, still the data is being made available. How? With the diagram what I am showing you now. Look at this concept, look at this diagram closely, and let me know you have any question. You see, I want to store a file called foo, which occupies 3 blocks, numbering 1, 2, and 4. Observe this once again. I want to store a file called foo, which takes 3 blocks, and those are being stored in such a way. If any of these 3 down, still 1, 2, 4 are available. You can do one thing, Vladan. Against my screen, what I am sharing, close one node with your fingers. Close one node with your fingers and check it out whether 1, 4 is available, 1, 2, 4 is available or not.
Yes, if we close the first one, so we have 2 available in the second cluster, second machine, and then 1 and 4 on the third one.
Absolutely.
So we still can access the data even though one is down. If it's the middle one down, we still have first and third with a part of the data or complete data.
Absolutely. So this gives you the understanding, even in the event of your node failure, still the data is being made accessible. Even in the event of data available, even in the event of data and node failure, still the data is being made available. Now I ask you one thing, who takes the responsibility of for storing your data in the form of blocks like this? Are you going to take care from your end as a developer that you distribute the data onto the nodes like this? Are you going to take that kind of care? Are you going to distribute on your own manually?
No.
That is quite not possible. So it is all the responsibility of the name node. You just request the name node, I want to store a file. It is the headache of the name node. It has got its own algorithm inside. How these blocks needs to be distributed onto different nodes in such a way that even in the event of the node failure, still the data is being made available. That is what the beauty part of your replication, and that is what the importance of the name node. It is all the headache of the name node. When it receives a request to store a file, it is going to identify how many blocks are required to store this file. Those many blocks are distributed on your cluster in such a way, even in the event of node failure, still the data is being made accessible. It is all the headache of the name node, nothing from your end. Right?
Right.
So usually we keep the replication factor 3 at the cluster level, not 2, but to have the understanding, I have shown you here the replication factor 2. But what is that? The replication factor of the cluster is usually 3. The same block is available in 2 other machines. So even in the event of your node failure, still the data is being made accessible. So with this diagram, you get the clear understanding of how data is being stored at the cluster level, right? So your name node is not storing any data. Your name node is not storing. That is why most of the times we say data nodes are the physical workhorses. They actually store the data, they actually process the data. But it looks the name node has stored the data and the job tracker is processing the data. No, name node is just name node is just tracking the data about data called metadata. What it is doing, it is just tracking what is the name of the file, how many blocks are there, where those blocks are present on the cluster, where the replicas have been present, all those details being made available with name node. That is why name node will carry only metadata but not the actual data. Actual data is been stored at the data node level. So you look at this one closely, you understand. A file called foo, which requires 3 blocks, and each block will have a unique identification, and those are being 1, 2, 4. So accordingly they are being stored. So even in the event of node failure, still I can get that file from other nodes, so that my process will not be, or my processing will not be impacted, right? So name node, secondary name node, and data node, 3 domains under HDFS. Now I would like to ask one more aspect here. Suppose, look at this cluster. If one rack is completely unavailable because all the nodes that are there in the track are connected to that switch, and using the uplink from that switch I get connected to the other switches. Now for some reason, if the total rack is down, then there is a possibility that the entire rack can be done. If a node is down, with the concept of data replication, it has been addressed well. But if the entire rack is down, then you are getting my point, Laden?
Yes.
If the entire rack is down, then what is the situation?
Then I don't think we can access that if the switch is down. I mean, if the switch is up, then I mean, yeah. If you said the rack, every rack has a switch.
Yeah. If that switch is down,
So if that, yeah,
then
then
the entire
the
rack
area is
becomes unavailable.
unaccessible. Yeah.
That possibility is there, then the cluster becomes useless.
Yeah.
That is why the data is being distributed in such a way. Observe here. What is the replication factor that usually we set up at the cluster? The replication factor usually at the cluster level is 3. I mean, one copy, this is original, and we have a copy 1 and copy 2 on different nodes. When I am setting up my replication factor 3, and I also enable rack awareness, then the data is distributed in such a way, this one and this one may be on the same rack, and one more copy will be in a different rack. This is rack 1 and this is rack 2. Even in the event of your rack failure, still the data is being made available. That concept is what we call it to be rack awareness. Rack awareness, if it is being enabled, the rack awareness is being enabled, then I will not be storing all the 3 blocks of the same data in the same rack. 2 here in this rack and 1 in the other rack, so that even in the event of your node failure, still the data is being made available. I hope you got the point what I am sharing here, Laden.
Yes, I got it.
That subject is what we call it to be, what we technically call it to be
Rack awareness.
Exactly. Rack awareness. One of the important aspect of your HDFS learning. Rack awareness. If rack awareness is being on or enabled, then name node takes initiation of distributing the data in such a way, even in the event of rack failure, still the data is being made available. Whose headache is this one now? It is a headache of the name node only, so we need not worry. It is a responsibility of the name node. I think now you understand why for name node, secondary name node, and data nodes, why they are being set up in that way is for that reason only. Make sense?
Yes.
So you may be asked a question in the interview. What is rack awareness and how you achieve it? Then what you say?
If we enable rack awareness, so we have a replication factor 3. So then the same data is accessible on 2 racks. So in case if one rack goes down, we still can access the data on a different rack.
Absolutely. So that your cluster is not being impacted.
Yes, and then the name node is distributes the data in such a way the data is available. So
Perfect, perfect. Because our ultimate goal is to get into the job that is possible only when you satisfy the interviewer. So we also need to be clear with our concepts, what we are sharing, that we need to be very clear and precise. Only when you'll be able to crack the interview. Right? So as I asked you to go through, that as part of, see, you can read books, you can read documents, stuff from the internet and all, but the best source all the times, as I told you, the best source all the times is your hadoop.apache.org. This is the best source to get all the necessary stuff. The best source. Learn about single node setup, cluster setup. You might have seen architecture. In architecture, hardware failure. Hardware failure. A HDFS instance may consist of hundreds or thousands of server machines. See here, hundreds and thousands of server machines they are saying. Server machines they are saying. Each storing part of the file system data. The fact that there are a huge number of components and that each component has non-trivial probability of failure means that some component of HDFS is always non-functional. Observe this one closely. Observe this statement closely. The probability of failure means that some component of HDFS is always non-functional. Some component of your HDFS may be a non-functional always. At any point of time, there is some or other issue happening. We keep on rectifying that one. When the number of data nodes increases, that is where I'm talking now, right? And then file system namespace. What do you mean by that? Is called FS image, file system namespace. The HDFS supports traditional hierarchical file organization. What do you mean by this one, Laden? Because each point in this document gives a lot of stuff in a very precise manner. That is why I advise you to go through this documentation whenever you find time, so that you get acquainted with the terminology and it makes more sense. What do you understand from this point? Supports a traditional hierarchical file organization. What is that?
That practically is constructed as even though it's can be hundreds of thousands of computers, we only see one file system with a
Okay.
one root.
Exactly. That is what the point I need. This entire file
And
system will have exactly one root. That is what hierarchical file system. There should be a root. Under root we have directories. I mean different paths. Under each individual path there can be again subpaths or subdirectories. That is what I mean by hierarchical. You take any typical hierarchical system. I mean, I don't say that every hierarchical system will have like this, but most hierarchical systems will have like this. A starting point, right? Right?
yes,
Maybe for the convenience we are studying like this, but the same you can study like this. The same, instead of we studying like this, the hierarchical, but only to understand we are saying like that, but we can study this hierarchical system like this, where this is my root. Under that we can have like this. Maybe under maybe say for example TMP. Under TMP we can have again, maybe under the TMP I have ABC. Under that I can have again XYZ. Under that I can go in that way. This is what I mean by hierarchical system or hierarchical file organization. A user or an application can create directories and store files inside these directories. The file system namespace hierarchy is similar to most other existing file systems. One can create and remove files, move a file from one directory to another, rename the file, all these things. How all these things can be done with the commands. And those commands are technically called as HDFS commands or FS commands. I mean file system commands. See, Hadoop commands means they may go a bit generic because using Hadoop commands, we also can work with job submission, job execution, job monitoring. All those things can be done with Hadoop commands only. But specifically, file system commands (FS). So what those are? What those are? What those are?
so file system commands. We can do
Yeah.
create files, create directories, remove files.
I'm connecting to my cluster now. I'm connecting to my my cluster now. I'll increase the font so that you'll be able to. I think you are able to see the font, everything now.
Yes, perfect.
So you see here Hadoop EFS, that is what we call it to be file system commands. We have the commands to copy. We have the commands to copy the data from, I think you see here, there is something called copy from local to HDFS. Copy from local to HDFS. Copy to local from HDFS. Within the cluster, we can use CP, that is copying. See, there are two things now here that you need to understand. There are two things now you need to understand. One is the local file system. Local file system and Hadoop distributed file system. Now, this is my edge node through which I connect to my cluster. So this edge node is also a machine. This machine will have operating system. Operating system will have file system, right? This file system is called local file system. On the same edge node, HDFS might have also been set up. But on this machine, the HDFS is only a part, not a complete HDFS. That is why in the concept before, each, you can see that here. What is the point they have given? What is the point they have given? You see the file system. Where we studied that point, just before we studied that point. A HDFS instance may consist of hundreds or thousands of server machines, each storing a part of the file system's data. Each is only a part of the file system data, but not the complete. Right? So, there are two things here, local file system and Hadoop distributed file system. Now, I got connected to my edge node. Whenever I say ls-al, what you are seeing here, this is your local file system. Hadoop EFS-ls, and when I say this one, whatever you are seeing here, this is called your Hadoop distributed file system. I want you to clearly understand this one and able to differentiate these two. Then only our next journey is going to be smooth. Otherwise, it is always going to be confusing to you. That is the reason why we are being given with the commands like, I think you see here, copy from local. So if you have your data present on your local file system, I mean your traditional CentOS kind of thing, that file can be copied into your HDFS. That is called copy from local to HDFS, copy from HDFS to local. That is why you have the commands copy from local to where? HDFS. Copy to local from where? HDFS. So that HDFS is standard because we are talking in the context of Hadoop. So copy from local means you are copying the data from local file system to distributed file system. That is what the meaning. And we have a command called CP, that is just copying within the cluster. And we have disk free, disk usage, find, get, mkdir, mv, put, rmdir. And in rmdir, we have we can recursively delete the contents of the directories, a lot of things. I think you notice here what we are trying to share. All these are called your Hadoop commands or file system commands. Specifically, not just Hadoop commands, these are file system related commands, FS related file system. And how you access your file system, even on your regular sudo cluster, you just type Hadoop FS -ls and /. Now, if you don't give any / and all, Hadoop FS -ls and don't give anything, what is it saying? No such file or directory. And you give here.
Because / is a root directory, so you have to specify.
Yes.
You have to specify the path.
Exactly. Exactly. That is how you are able to see here. I think you noticed. Under TMP, you have all these things. Under TMP. So the file system namespace, data replication, and what data replication I have explained you. A data replication, you can go through what is rack awareness and safe mode. What is safe mode? You got a chance to go through this one, Laden? Safe mode.
No, I haven't read that one yet.
Okay, no issue. So safe mode is something, the moment you start your cluster, okay, till all the services are up and running, your file system should not be made accessible, right? See, when you take regular, observe this one very closely, Laden. This is what your regular CPU, and you have a power button here, and you just on this. Just on this, can you start immediately working? You just press that power button and you start working with your computer. Open the browser and start browsing something, or open WordPad or Word or Notepad kind of thing and start working. Possible?
No, you can't. No.
You must wait for some time, right? Maybe a
Yes.
minute or two, depending on how you have tuned your operating system. You need to wait, right? For maybe for a minute or two. What is going to happen during that time? Or what might have happened? All the necessary things are being loaded and being able to set up properly so that you'll be able to use it. Same like, even when your cluster is on, it is not accessible immediately. It takes time. It takes time. What it is been saying. So initially when the cluster is started, by default it is going to be in the safe mode. By default it is going to be in the safe mode. During safe mode, file system related operations cannot be done. Either creating a file or deleting a file, whatever it is. That is why we need to ensure Hadoop EFS you see here Hadoop DFS admin I am saying here, Hadoop DFS admin hyphen safe mode. Hadoop DFS admin what it is saying? What did he saying?
That the safe mode is off.
Only
Now we can use the command.
exactly. Only when the safe mode is off, you will be able to access your file system and perform all the operations. But your name node is still cluster has started, everything is okay. For whatever the reason it is, your name node is still in the safe mode. Then what happens? Your cluster is not going to be accessible to perform CRUD operations. I mean, create, retrieve, update, delete kind of operations. Got it?
Yes.
So once your cluster is on, it should your name node should automatically come out of the safe mode. Automatically comes out. For any reason, if it is not able to come out of the safe mode, then we have the command to bring it out of the safe mode. What is the command? Hadoop DFS admin, Hadoop DFS admin hyphen safe mode. It is saying get is to get the information, and we have other options available for enter, leave, and wait. Enter, leave. You can make your name node to enter into safe mode. You can make your name node to leave the safe mode. You can get the status of the safe mode, or you can ask your name node to wait, to be in the safe mode. So depending on what you need, you can perform that. But any file system related operation is possible on your Hadoop distributed file system only when the name node is not in the safe mode. I think you get that point when you study this one. On startup, the name node enters into a special state called safe mode. Replication of data blocks does not occur when the name node in the safe mode state. The name node receives heartbeat and block report messages from data nodes. A block report contains a list of the data blocks that data node is hosting. Each block has specified minimum number of replicas. The block is considered safely replicated when the minimum number of replicas or that block has been checked with the name node. After a configurable percentage of safely replicated blocks within the name node, what it happens that still have fewer than a specified number of replicas. The name node then replicates these blocks to the other data nodes. See, when everything is being set up, replication and the data is now being made accessible, even in the event of the failure, when all those things been done and been taken care, then your name node usually leaves the safe mode, and then your Hadoop distributed file system becomes accessible. But during the process or the path of your um, your system, your distributed file system is getting up and all, when your name node in the safe mode, no operation is allowed. Operations are allowed on the distributed file system only when the name node safe mode is off. Otherwise, you will not be able to perform any operation on the cluster. Make sense? The persistence of
Yes.
file system metadata. You can
Can I
just
ask you a question? Sorry.
yeah, please.
It says over here, and then determines the list of data blocks that still have fewer than specified number of replicas. So who is that? A name node? Is the name node set up to make certain amount of or number of replicas, or that's administrator's job to set up name node to
No, physically it is
do
been
certain
handled by.
percentage?
Now, physically it is been handled by name node, but logically it is been set by the admin. Based on the admin instruction only, the name node will replicate the data. But that is been set by the
So
admin, been implemented by the name node.
okay, I understand this because it says after a configurable percentage. So that's probably depends how big the cluster is, right?
Exactly.
the bigger cluster, then the more replicas we have, because we have more storage.
More storage, but replication factor we keep usually at the 3 only, until and unless it is more sensitive, important, something like. We don't do that.
Okay, got it. So 3 only. Okay.
Yeah, 3 replication. Right?
Okay, thank you.
So I advise you to go through even this persistence of the file system metadata and all. That is why, Laden, why I encourage you to go through this content. I know when you go through this content, you will get lot of doubts, and you will bring back those doubts to me, and I'll be, I need to answer all your queries and all. I know all these practical things, but still I encourage. See, most queries what you get, I am in a state to answer them without any problem. And beyond something, if I'm not able to answer, you bring those kind of queries, I'll be very happy, because that is how the knowledge is being enhanced or enriched, right? So I advise you to go through this technical documentation for the reason you get a lot of questions, you get a lot of stuff. When you are more stuffed, facing the interview is going to be more easier, right? So you require a lot of theory to face the interview. You may not need more theory to understand the concept. I am doing that one in the session. But to face the interview, you require more stuff and you require more technical terms to be used. Only with your ability, you are going to crack the interview, right? So I advise you to go through this one. I understand that it is not that easy to go through this documentation, sit and read all these things, but you must pass through that phase. There is no other alternative for us, right? So you got a chance to work with file system commands by any chance, Vladan? Like what I'm doing now, Hadoop fs-ls and all. You got a chance to work with those things?
Yeah, I kind of skimmed through. I didn't like read detail, but I did kind of go through. It's a lot of commands are similar to Unix, Linux commands.
You are absolutely right. That is the reason
Yeah,
why.
like a lot of
Most
commands are
open
familiar to me.
source. Yeah, go ahead, go ahead.
No, I just said like a lot of commands are already familiar to me, like a file system commands.
Yes.
There are a lot of there are a certain percentage of these commands that I never used regarding to databases, so I didn't use those, so I have to learn those.
But I advise you to run these commands, Laden, and check it out what is happening at the file system level. When you copy some file
Sure.
from the local file system to HDFS, through one user, is it accessible to the other user? All those things you check it out and get your own conclusion. Then you'll be able to understand how you restrict the accessibility or how you give the accessibility and all. Right?
Okay. Yeah.
Go through it, what best you can, regularly, not just 1 day or 2 days, regularly, so that it makes more sense.
Okay, so I should start learning commands
Yeah.
as of today, huh?
Yes.
Okay.
Yes. Right. And you also study this theory, whatever is been given here, so that you will be able to get a lot of insight. And more stuff I'll be explaining it, and you need not worry. I mean, it is going to be covered in some other form, but not to the extent the whole theory that is there as part of the documentation, right? So whenever you find time, just go through this one in a continuous fashion so that you'll get updated. Okay. Now, one other thing that we need as an admin, what we are doing now here. I think you noticed what we are doing here. What is that? Okay. I think this might have got. All right, you see here, Hadoop FS we used just before, right? This is what I told you is these are file system commands. That is what I mentioned it. Hadoop FS, and when you say you get all that. Same like Hadoop FS, we have Hadoop DFS admin. Hadoop DFS admin. Hadoop DFS admin. I think you noticed here, all these are called distributed file system administrative commands, which can only be run as a HDFS super user. That is nothing but, usually the Hadoop admin, right? Hadoop admin responsibility, which are more specific to us. Are you getting the point, Laden, what I'm saying?
Yeah, so these Hadoop DFS admin commands, is that like a elevated privileges?
Pardon?
So if you run the commands as a Hadoop DFS admin, so that's practically you have elevated privileges, or what? Is it like a root user or
Oh,
just
no.
admin?
Now I'm a root user, but user management is
Oh,
already
okay,
there,
got it.
that we'll be discussing. So you should be a Hadoop super user, HDFS super user, to run these commands, because all these are related to your file system. You can save the namespace, and you can set the space quota. You can refresh. You can get the reports of your nodes. How you get the reports? Block report. Okay, so all these being related to the file system, which are very sensitive, we will not allow normal users to work with them or access them. That is why HDFS super user only can access these commands, and that is nothing but the Hadoop admin. Hadoop super user is nothing but Hadoop admin only, right? You got the point?
Yes, I got it. Thank you.
So these commands, I mean, just have a look at it. We are not going to use these commands regularly, but still we need to have an idea what each command is going to do. Hadoop DFS admin. That is what we are saying here. Hadoop DFS admin. These are the commands what we have, right? Just go through this one, Hadoop DFS admin command, so that we see how we utilize those commands when we start working with the file system as a Hadoop admin, right? Just go through it. And one other thing that I want you to go through is, let me take you over there. You can see that one here, Ladan. In order to provide the accessibility to your file system, I think you see, to any platform, the core infrastructure is your file system hierarchy. On the top of that only other things are being built. Until and unless you store the data, you will not be able to process it, you will not be able to do anything. So if data is not being stored properly, then the processing also going to be impacted very badly. That is why our entire concentration at the initial stage is surrounding storage only. Only when we are clear and comfortable with the storage, we will not be able to work on anything with processing. That is why we are trying to look into this aspect. I think you have seen here in the same HDFS, I think you noticed here, along with commands reference. We also has got the other concepts like viewfs. What is viewfs?
The view file system.
Exactly. viewfs is just nothing but the view file system, the utility through which you are going to access the file system, not more than that. Okay, I advise you to go through this one. Certain aspects you will not be able to understand, like what been shown here. We need to discuss that one. Okay, so we are going to focus on that now. See here, your entire cluster, as you know, runs on the same concept of master slave, either HDFS or your MapReduce, master slave architecture. Let you take HDFS or you take MapReduce, both has got the same. Now, these being your name node, your secondary name node, and your data nodes, all these aspects, they run as daemons, right? When they run as daemons, you definitely need to provide some configuration to them, right? Definitely need to provide some configuration means it is a confusing term again to you. That is the reason why if you look closely here, what is being shown, there is a file called core-site.xml of each cluster as a configuration property that set the file system to the name node of that cluster, where all these configuration details are maintained, where the cluster configuration details are maintained, all the cluster configuration, even your MapReduce, anything in the entire Hadoop ecosystem, all those are maintained in the form of XML files. All those are maintained in the form of XML files. Simple and easy to understand XML files. These are not complicated files. Inside each XML file, we have set of properties. And each property has name, value, and description. Name and value are must, description is optional. Name is always a string, but value is always, it need not be string, it can be number or string or anything. I'm going to show you now. Let me take you over there.
So all configuration files in those are in etc directory, right? Those are all written in XML.
Exactly. Those files are present in different paths because HDFS configurations are present in one path, MapReduce configurations are present in other path, and your pig configurations are present in one path, Hive configurations are present in the other path, but all configuration files will have the same structure. That is what I mean to say. You got the point what I'm saying?
Yes.
See here, I'm going to show you this path. This path is slightly different from your path, Vladan. I mean, on a pseudo cluster, this path may be slightly different. This is a live cluster. This is a live cluster. So if you look at this one closely, inside this lib, I think you noticed, what is that? For every Hadoop component as part of the ecosystem, we have a directory again. I think you noticed for Hive, for Pig, for Scoop, for Uzi, Impala, HBase, Yarn, and Mahout. You see separate directories there?
Yes, I see it. Yeah, Spark, Scoop, Zookeeper.
Yes, you're right. Now I went into this one. Hadoop HDFS. You will see all the stuff related to Hadoop HDFS here. Got it?
Yes.
Same like just have a look at whatever we have. I'm showing you here. You notice there is a file called core-site.xml.
Yes, that's exactly one that I was looking for.
Yeah. So when you look into this one, it's a root element. In this one, the root element is configuration. You take any XML file, any configuration XML file in the entire Hadoop, not only HDFS Laden. Tomorrow you go to Pig, Hive, Scoop, anything. All XML files will have the same root element called configuration. Under root called configuration, we can have number of properties. Each property will have a name value and optionally description. Name, value, sometimes we will have description also. Description is optional. Depending on this thing, it may or may not be present. Okay, name, value, description. There's one more thing called final, which takes true or false. We talk about this one, don't worry. Which takes only true or false. What we mean by true and what we mean by false for a property, we will talk. But each configuration file will have number of configuration parameters or properties in the form of name value pair. Okay. So whenever your daemon is starting, it reads all these configuration details and accordingly it runs. That is what I want to bring it to your notice. That is the reason why I opened this one, so that you will be able to understand what these configuration files are. I think you notice that one here when you are going through this documentation. There is something called core-site.xml file. In that you see fs.default.name. You can go there and see it now. What is that property? This is a path which shows you your HDFS path. I mean, this is how your HDFS is accessible from external world. This may be more related to the developer, but still you need to know. That is why I'm sharing with you. You understand looking at this one, Laden. Tomorrow, you are writing any customized Java code to access your file system. If you want to access your file system, then you should have a way to access that one, right? How you access your website? Using your URL. Same like if you want to access your Hadoop distributed file system, you require a URL. That is what the URL that is being shown here. You got it?
There is this value, right? HDFS, and then the
Yes.
kind of value, right?
So that HDFS is a protocol, like how you use HTTP, HTTP,
right?
and www, like you are saying, right? The same when it comes to this one, it is the URL. The protocol is HDFS protocol. This is the domain, nothing but the IP address in the form of a name, the port number. Now, please understand this one. This is my file system under root. If I want to use /tmp from external world, how I can access that? This URL, this URL /tmp is the full path. When you are connected to the cluster, you can directly access the file system. But when you want to access the file system from the external world, from outside the cluster, then this needs to be given. /tmp will make that directory to be accessible. It makes sense, Laden?
Yep.
Are you following with me?
Yes, got it.
So this is a file system present in your root as part of the cluster. But this /tmp is visible to you when you are connected to the cluster. But if this needs to be visible from outside, then it should be given with the complete path. Where that complete path is been described, that complete path is been described with this property in a file called core-site.xml. What is a thrash interval and what is a compression codex? What is a security authentication authorization? All those details are being specified as part of your configuration file here. The file name may be different: core-site.xml, hdfs-site.xml, mapred-site.xml, yarn-site.xml, pig-site.xml, hive-site.xml. File names may be different, but all the file architectures are the same. Inside each configuration file, we have the same structure. We have the root tag called configuration. Under that, we can have number of properties. And each property is a name value pair. So I advise you to go through all this stuff before we meet in the next session, so that it is going to be more easier and effective for you. What all the best you can, please go through this one. Okay, continuously over a period of time you will gain more knowledge, and you become more skilled in understanding these things. Along with HDFS, I advise you to go through yarn. MapReduce you don't need, because that's all part of the development, but architecture we require. MapReduce architecture, how the job is going to run, that I will explain you. But HDFS and yarn, try to understand and get whatever best that is possible from this theoretical documentation. Other stuff we cover as part of our discussion.